Hello everyone, welcome to another lecture of vector calculus, and this is lecture number 8 of mathematical physics. And here we're going to discuss about gradient, normal and directional derivative. And I have provided the lectures, link of the previous lectures in the description box. So if you haven't watched them, go through them for better understanding. Okay, and in this lecture we're going to solve some problems, very important problems related to the topics we have discussed here. So now let's start. Before we start, please subscribe the channel if you are new to my channel, and if you think that this video is helpful and if you enjoy the video, please share with your friends, hit the thumbs up button, and also hit the bell icon as well, so that you get notified when new video will be uploaded. Okay, so let's start. Now gradient, what do you mean by gradient? Suppose we have a scalar point function, so phi, which is a function of x, y and z. Okay, differentiable at each point x, y, z in a certain region in the space. Then the gradient of phi is given by grad phi, or it represented by the symbol nabla. This nabla symbol phi, this is called nabla, right? So this is equal to I cap partial derivative of phi with respect to x, and j cap then again partial y, right? Then again k cap then partial derivative with respect to z, right, of phi. Or you can write this way, in this manner also you can write that, right? So now you see this is a vector quantity, so grad phi is a vector quantity, right? So now you can see, yes, phi is a function of three different variables, right? Three different variables x, y and z. So its total derivative or total differential is given by d phi is equal to we have to differentiate along x, right? This d del phi by del x represents partial derivative. So I will tell you about this later. Then dx plus del phi by del y dy, then del phi by del z dz, right? So here you see, suppose you have a function f of x, it is a function of one variable, that is y is equal to f of x. Then its total derivative dy can be given as, so dy by dx will be f dash x, suppose. Then total derivative dy is given as f dash x dx, right? So but here you can see that it is a function of three variable. This phi is a function of three variable. So del phi is given by sum of del phi by d phi, that is total derivative is given by derivative d phi is given by this result. Okay, so now you can see that here, what do you mean by partial derivative del phi by del x? So when you take the expression, when you take this function x the phi, or it is a function of x, y, z, if you differentiate with respect to x, you will assume that y and z are constant when you take partial derivative, right? So that means you can see, when suppose, so let me take this one, suppose your phi is equal to x square y plus z, suppose. So when you find del phi by del x, then you will consider x as a variable only, other remaining terms will be constant. So here we will get twice x, then y plus derivative of constant is 0, so we're gonna get this, right? So that is that's how we used to find partial derivative. So hope you have understood this, right? Now you see, from here what we can do, so let's move on to next slide. So we have got grad phi is equal to this, right? Let me write it again. This is grad phi. So this is a vector quantity, and position vector of a point x comma y comma z is given by this r vector, suppose, then this is position vector of this point on the surface xyz. This is on the surface represented by this function, right? And this total derivative of this position vector will be given by this del x I cap plus del y j cap plus del z k cap, right? Then total derivative del phi that we have already written in the previous slide. Let me write it again here. So this is the total derivative, right? So it can be expressed as a product of two vectors, right? Dot product of two vectors, this one and this one. So we can express this as a dot product of two vectors. Okay, if you multiply this one and this one, you will get this term. This one and this one, again you will get this term, and this one and this one, you will get this term, right? So if you multiply this one with other two terms, then it will be 0, right? You know that things, because I dot I is only 1. If you find I dot k, that's gonna be 0. K dot j, that's gonna be 0. You know these things, I hope. And so after that, what we're gonna have here, so here you see this is nothing but grade phi, nah? So here you can see this is grade phi, right? So and this is nothing but total derivative of vector r, right? So we can write this way, a dot product of these two vectors, and dot product of two vectors a dot b is given by what? ab cos theta, or you can say magnitude of a into magnitude of b cos theta, right? So in that case we can write here magnitude of grade phi into magnitude of total derivative of r cos theta. So here theta is the angle between these two, grade phi and the dr, and we know cos 0 is 1 and cos 90 is 0. So when your theta is 0, then it is maximum, and when your theta is 90, then it's minimum, right? So you will get the greatest value of d phi, right, when theta is equal to 0, because we get maximum when cos 0, when we take theta is 0, cos 0 is 1, right? So because of this region, because of this property, we give the name of this as gradient of phi, right? Now you see normal and directional derivative. Suppose we have a function, this one is equal to c be a family of surfaces. So this represents this equation represents a family of surfaces, right? So let us hope that way, and for different values of the constant c, right? So if you put different values of constant c, you will get different surfaces, right? So for one particular value, you will get one surface represented by this equation, and if you put another value of c, then you will get another surface, right? So then the total derivative of phi, that is d phi, will be 0, right? D phi will be 0 because c is constant here, right? So d phi, we know it can be represented as dot product of these two vectors, that is magnitude of del grade phi and magnitude of total derivative of vector r cos theta, that's going to be equal to 0 here, as c is a constant, right? Now this 0 right hand side, this 0 can be written as magnitude of grade phi minus magnitude of dr vector cos 90, because cos 90 is 0, right? So that's going to be 0 then. So comparing left hand and right hand side, we get theta is equal to 90, right? So that means you can consider that these two vectors are perpendicular, right? Suppose you have a surface here, this point is suppose x comma y comma z, and here this dr, total derivative of position vector r, will represent the tangent, right? Will represent the tangent, and as grade phi is normal perpendicular to the vector dr, right? So that's gonna be perpendicular to the surface, that's normal to the surface, you can say. Grade phi represent normal to the surface. So we can write this total derivative of r is tangent to the given surface, and grade phi is the normal to vector to the surface represented by this equation, given surface, right? So, and if you find a component of grade phi along a given in the direction of a given vector, suppose that vector is suppose d vector, so then you know how to find the component of a given vector. How to find the component of a given vector? Suppose you need to find the component of vector a along vector c, then what you gonna do? Then you will multiply vector a with the unit vector of c, right? You do that usually. So same thing we're gonna apply here. So we will do what? Grade phi dot d cap means unit vector of d vector, right? So this is gonna give you the directional derivative. This is called directional derivative of grade you can say directional derivative of phi actually. So let me write here phi along along vector d. So this gives the directional derivative along vector d. So hope you have understood this. So now let us take a question. Suppose your phi is equal to this is your phi. Then suppose we need to find grade phi, or yes, at the point 1 comma minus 2 comma minus 1. So then let me write what is phi given in the question. So then grade phi, we know that is given by partial derivative of phi with respect to x I cap, and that of phi with respect to y j cap, and that means partial derivative of phi with respect to z k cap, right? So let's find d phi by del phi by del x. So here we're going to consider when you find del phi by del x, then what you will have. So here you see del phi by del x. So phi is your thrice x square y minus y square z square. Here you see we're going to consider y, z, these are constant when you are going to find partial derivative, right? So if you differentiate this, then you will get 6x, right? And y remains y because it is constant, and here we have no x, so it's going to be 0, its partial derivative will be 0, so we have got 6y. So that's how we're gonna do. So hope you have understood how to find a partial derivative. Okay, so that's I cap should be written here. Then again, if you find a partial derivative with respect to y, you find a partial derivative with respect to y, 3x square y minus y square yz square. So here you see we're going to take this part as constant. So if you differentiate y, dy by del y, that's going to be 1, right? So here 3x square minus, so if you differentiate this y square, then you will get twice y, then z square should be considered as constant, right? We're going to get this. So let me write here what we have got after getting the what we have got. The partial derivative of this phi with respect to y is this. So this is z cap. Then similarly you can find the partial derivative. So here we have minus, and this first term doesn't contain z, so it's going to be its partial derivative with respect to z going to be 0. So we have got minus twice y z k cap, right? So that's what we have got. So hope you have understood how to get the partial derivative, right? So now at the point this is the given point. Here del phi will be if you put the values of x, y, z here, then you will get this. So let me write here. Curl bracket is being used here. Okay. So now if you calculate this, you will get this vector, right? So now you see we have got grade phi. So this is your answer. Now next question, find grade phi if so I have written if twice, so let me clean it. So if a is equal to there are two questions. First one, phi is this is your phi. Ln means natural log of so ln of mod of vector r means natural log, that is log where base is e of vector magnitude of vector r, right, represent this. So hope you have understood the meaning of ln. So now b, here phi is 1 by r, mod of r you can say, or simply r. So r vector is given by this, you know that. Let me take that way. Now let me write what is r here first. This is your r. So mod of r will be root over x square plus y square plus z square. That can be written this way: x square plus y square plus z square whole to the power half, right? So grade phi is given by del phi by del x I cap, del phi by del y j cap, del phi by del z k cap, right? So now for the first one, that phi is equal to natural log of vector mod of vector r, so that's gonna be log of x square plus y square plus z square whole to the power half, right? So using the properties of log, you know that log m to the power n, it can be written as n log m, right? So let us use that property here. So if you use that property, what you will gonna have, then half ln x square plus y square plus z square, that's what we're gonna have, right? So therefore so to find grade phi, let us first differentiate this phi with respect to x. Okay, if you differentiate this with respect to x, then what you will get? If you differentiate this with respect to x, we know ddx of log of x is 1 by x, right? So if you use that way, if you compare this one with x, then you will get 1 by x square plus y square z square, right? Then again, it is not actually x, it is x square plus y square plus z square. Again you have to differentiate it, x square plus y square plus z square. So here we are taking partial derivative, so we are going to take this y and z as constant, as if you are if you are differentiating with respect to x, so these two will be 0, so here we will get twice x, right? So here we have got twice x, these two cancels, right? Similarly you can find del phi by del y, so you will get the same result, but instead of twice x, here you will get twice y. Okay, you will get twice y, right? Because these two cancels, because you can see here. So when you will find this, let me clean here. Now when you will find del z ln x square plus y square plus z square whole to z square, so half was all there, so this half is written outside, so then you will get half into 1 by x square plus y square plus z square. Then again you have to differentiate this, right? If you differentiate the terms within the bracket, so here as we are going to differentiate these terms within bracket with respect to z, so that's why we will take x and y as a constant, and derivative of constant is 0, so here we will get z square only. So if you differentiate this with respect to z, then you will get twice z here. So that's why what we have got, so that is why we have got that del phi by del z is equal to this one, right? So 2 will be cancelled again. Now put I cap, j cap, k cap here. Okay, I cap, j cap, k cap. Now if you take LCM, then what you will get? This one, and this is your numerator. So this is your r, this is your r vector, right? And this one is your magnitude of square of magnitude of r square, right? So magnitude of r is this, so if you square it, then you will get this result, right? So this is your answer. So now let's solve this one, second part, that is phi is equal to 1 by mod of r. So magnitude of r, that means. So let me write the mod of r here, and grade phi is this, that we know that grade phi. What is grade phi? So now if phi is equal to 1 by mod r, then let's put the value of mod r here, that is to the power half, and it can be written as x square plus y square plus z square to the power minus half, right? So here you see I forgot to write the square here. Okay, grade phi. Now again we know that derivative of 1 by root x, that is x to the power minus half, is given by this, right? That's going to be minus half x to the power 3 by 2. Now compare this one with this result. Okay, then what you will get? If you differentiate with respect to x, you will get this, right? Then again you see this is function of function. You need to differentiate the terms within the bracket, right? As you are taking del phi by del x, so you have to consider y and z as constant, right? You will take x only variable. If you differentiate this x square, then you will get twice x here, right? So then I kept. So now similarly you can find del phi by del y. You will get this result. And similarly you can find wait, let me clean this. Similarly you can find del phi by del z also, right? This is k cap. So hope you have understood this. Here 2 cancels, right? So here you can take common, right? These 3 terms. If you take this common, then you will get minus 3 by 2 here. Then within bracket you will get minus x I cap minus y j cap minus z k cap, right? So now you see this can be written as minus x, taking minus common, you can write this one, and here you will get x square plus y square plus z square whole to the power 3 by 2. Now you see this denominator, it can be expressed in this way. Let me show you. Whole to the power half, then whole to the power 3. You can express this way, right? So then you see this is nothing but your r, or mod of r vector, and here you can write this is nothing but your vector r, right? This is your vector r. So you will get your answer this way, minus r vector divided by mod of r cube, right? So this is your answer. So next question is, find the unit normal vector to the surface. This is your surface, right? And at the point this P111, right? So let me write the given surface first. So this is the given surface, right? Take the left hand side as phi. This is your phi, right? So now let's find grade phi first. I have already shown you how to find a grade phi, so just find a grade phi. This is your normal vector to the surface at this x y z, right, at this point. So let's find del phi by del x is this. So if you find a del phi by del x, you will get this, right? So now del phi by del y, I have already shown you how to find those partial derivatives. Then your del phi by del z is this. So now at this point, so if you put x y z, it's 3, sorry, each of them 1, right? In these 3 terms you will get here you see. So what we have done here, so if you put 1, this term will give you 6 minus 12 I cap, then this term will give you 1 minus 4 j cap, then this term will give you 3 minus 24 k cap, and that's going to be equal to minus 6 I cap minus 3 j cap minus 21 k cap, right? That's your grade phi at this given point P, which is 1 comma 3 comma 1, right? And vector D is our, this is your vector D, 2 I cap minus j cap minus 2 k cap. So D cap will be unit vector, right? Unit vector of D will be vector D divided by its magnitude, right? So how to find a unit vector of a given vector? you know that if d is the vector, if you need to find a unit vector, that is d cap, then you have to divide the vector d by its magnitude, right? And that means its magnitude is this one. So that's how we do, right? So you know these things, these are very basic things. So that's what we have got. That's right. So if you find this value here, you will get root over 4 plus 1 plus 4, that's going to be root over 9, that is 3. So here we have got 3, right? So directional derivative of phi at this point is given by del grade phi, not del, grade phi dot d cap. That's gonna be right, this one. This is your grade phi, and dot, you have to multiply d cap, right? And d cap is your this one, this is your d cap. Now cancel these 3 terms by 3, then what you will get? You will get 217, right? So when you cancel 6 by 3, you get 2, 3 by 3 1, 21 by 3 7, right? Now multiply this 2, then what you will get? Minus 4 plus 1 plus 14, and that's gonna give you 11. So this is your answer. That's how we can find the directional derivative along a given vector. Our next question, so that grade r to the power n is equal to n r to the power n minus 2 r vector, where r vector is given by this, you know that. So let me write the given vector r vector first. This is your r vector. So mod of r, or simply you can say r, that's gonna give you x is a root over x square plus y square plus z square, that is nothing but x square plus y square plus z square whole to the power half. So grade r to the power n will be given by partial derivative of r to the power n with respect to x, I cap, then partial derivative of r to the power n with respect to y, j cap, then partial derivative of r to the power n with respect to z, k cap, right? So here r is this one. So r to the power n we will get x square plus y square plus z square whole to the power n by 2, right? Now if you differentiate this with respect to x, if you find a partial derivative, then what you will get? You're gonna get this, right? So take this one as again, you see this again you have to differentiate the terms within the bracket, because it is function of function. If you differentiate this, then you will get 2x right here. So similarly you can find partial derivative of r to the power n with respect to y, right? So but here result will be same as this, but instead of twice x you will get twice y. That is the only different, right? Only difference you will get. So let's do it. Similarly, let's find del partial derivative of r to the power n with respect to z, that's equal to this one, right? So hope you know how to find a partial derivative. I have already shown many times, right? So 2 cancels here, right? So I cap, j cap, k cap, put the I cap, j cap, k cap here. So finally what we have got, on taking these terms common, right, we have got this, then within bracket x cap, x I cap, y j cap, z k cap, right? So here you can see this is nothing but this can be written as whole to the this to the power half whole to the power n minus 2, right? So this is your r, right? And this is your r vector. So this is your r, right? So what we can write now, you can replace this one by r, and you can replace this one by r vector, right? So you can see r is nothing but what, this is your r, right? This is equal to, this is your r. So you can replace this one by r, this one by r vector. So this very so finally what we have got, n r to the power n minus 2 r vector, right? So this is the right hand side, this is your right hand side. So hope you have got it. What we have done, this is nothing but your r, right? This is your r. And this is your r vector. So we have put that. Okay, so this is the right hand side. So that's all in this lecture. So hope you have understood what I have explained, and if you have understood, do share with your friends and hit the thumbs up button. And if you are new to my channel, subscribe the channel, also hit the bell icon as well, and see you in the next video. Thank you for watching.